When we wish to distribute similar objects in a certain way, we can do it quickly if we use one of AutoCAD's array tools. There are three types of arrays in AutoCAD: the rectangular array, the polar array, and the path array. We can create 2D patterns using the array tools, but we can also create 3D patterns with the very same tools. In this video, we will learn how to create arrays in 3D space. In the drawing area of the open file, you can see a rectangular array. A rectangular array distributes object copies into any combination of rows, columns, and levels. The array in the example consists of 3 rows, 5 columns, and 3 levels. To create a similar array, I will activate the rectangular array tool. The rectangular array tool can be found in the Modify panel of the Home ribbon. Alternatively, you can type Array in the command line and press Enter to activate it. Once the tool is active, I have to select the objects I want to distribute, so I will select the box and press Enter. As soon as I pressed Enter, a preview of the rectangular array with 4 columns and 3 rows of boxes appeared. Furthermore, the Array Creation ribbon appears with all the necessary settings for the array. In the Columns panel, I can specify the number of boxes in each row and either the distance between them or the total distance the entire row will cover. I will change the value in the Columns field to 5 and the value in the Between field to 4. Notice that the value in the Total field was updated automatically. In this way, each row will have 5 boxes and the distance between the boxes will be 4 units. Next, I will move on to the Rows panel and I will increase the number of rows to 4. I will also set the distance between them to 2 and notice that the value in the Total distance field is updated automatically. So now there are 4 rows and the distance between them is 2 units. In the Levels field of the Levels panel, I can define the number of levels on the Z-axis. I will type the number 3 in the Levels field, and then I will also change the value in the Between field to 2.5. Again, the value in the Total field was updated automatically. As you can see, at this point the array has 3 levels and the distance between those levels is 2.5 units. I should mention that the distance is measured from the base of the first object to the base of the second object. Once I make all the changes I want and the array is how I wanted it to be, I will click on Close to deactivate the tool and see the final result. At this point, I will move on to the next example to show you the next type of array, which is the polar array. Polar arrays evenly distribute object copies in a circular pattern around a center point or an axis of rotation. In the open file, a polar array of 21 items has been created in advance. As you can see, this array has 3 levels and each level consists of 1 row of 7 items. The Polar Array tool can be found in the Modify panel of the Home ribbon. Once the tool is active, I have to select the objects I want to distribute, so I will select the box and press Enter. Then I need to specify the center point of the array, which will be the center of the circle. As soon as I clicked on the circle's center, a preview of the polar array appeared. In addition, the Array Creation ribbon appeared with all the necessary settings for the array. In the Items panel, I can specify the number of boxes in each row and either the angle between them or the total angle they will fill. I will change the value in the Items field to 10 and press Enter. Notice that the angle fields were updated automatically. In the Levels panel, I will now increase the number of levels to 3. Naturally, I can always change the distance between the levels, but in this example, I won't do it. I won't create any more rows either. As soon as the array has the desired result, I will click on Close to deactivate the tool. Notice the final result. Let's move on to the next example to show you the last type of array, which is the path array. As its name indicates, it distributes items along a line or a curve that works as a path. As you can see in this example, a path array has been created and the path is a polyline. To align the box with the path correctly, I will select the box first and move it on the polyline. I will set the base point at the midpoint of its lower edge and the second point at the end point of the polyline. Now that I'm ready to create the array, it's time to activate the Path Array tool. The Path Array tool can be found in the Modify panel of the Home ribbon. Once the tool is active, I will select the objects I want to distribute, namely the box, and I will press Enter. Next, I need to specify the path of the array, which will be the polyline. As soon as I clicked on the polyline, a preview of the array appeared. In addition, as happens with every type of array, the Array Creation ribbon appeared with all the necessary settings for the array. In the Items field of the Items panel, I will type the number 10 and press Enter. In the Levels panel now, I will increase the number of levels to 2, and then I will also change the value in the Between field to 3. As soon as the array has the desired result, I will click on Close to deactivate the tool. In the last example, I will show you how to create a different path array. As you can see, a spline has been created in the XZ plane instead of the XY plane. In addition, the object that I will distribute has been placed on the base of the spline. So, to create the array, I will activate the Path Array tool, select the box, and press Enter. Then I will select the path. In the Items panel of the Array Creation ribbon, I will change the number of items. Notice that the object followed the three-dimensional path and was aligned accordingly. You can also increase levels like you would normally do in any type of array. Once done, I will click on the Close button to see the result.